Who's that? I can't see you. Woman.
Okay, now this chapter we will be looking at riveted joints. Okay, riveted joints. Now before that, we will be looking at the terms that we use in this section. Now, what is a riveted joint or a rivet? A rivet is a short cylindrical bar with a head integral to it. The cylindrical portion of the rivet is called the shank. Okay, or body and lower portion of shank is known as the tail. Now, the rivets are used to make permanent fastening between the plates, such as in structural work, ship, buildings, bridges, tanks, and boiler shells. Now, the riveted joints are widely used for joining light metals. Now, then we have lap joint. Now, a lap joint is that in which one plate overlaps the other and the two plates are then riveted together, joined together. So this is the example of lap joints 1, 2, and 3. So we have the first one is called a single riveted lap joint here. This is called single riveted lap joint. Okay. So when you refer to this column here, you can consider this as a single riveted lap joint. But then when you refer to the second diagram, you have two columns, and we call it as double riveted lap joint. And then the third one is called the chain riveted, or we call it as double riveted lap joint, but it is zigzag riveting. No, sorry, the second one is called chain, the third one is called the zigzag. Okay, but then the number of rivets is still considered as 2 in the diagram B and the diagram C. Here you can see 1 rivet, 2 rivet, so that is why it's called as the double riveted lap joint. Now these are the examples of rivets. The body here is called the shank. This is called the head. This is called the head, the shank, and the bottom part here is actually called the tail, but it is not shown here. So then the next one is the butt joint. So a butt joint is that in which the main plates are kept in alignment, in alignment butting or touching each other, just like this. Okay. So we call this as a butt joint. Now, each other and a cover plate, so you will have a cover plate on top. Okay, so you have two plates placed side by side to each other, and then you have a top cover plate or a bottom cover plate. So you have single cover or double cover. So if you have both top and bottom, then we call as double cover. Okay, or double strap butt joint, or is a single strap butt joint. So I have examples here. So you can look at diagram A and diagram B. So these are the two plates shaded in blue, okay, which is placed side by side to each other. We call this as a butt joint. Now, but then when you look at this section which is shaded in red, is called the cover plate. They are called the cover plate, and sometimes it's called the strap plate. So you have one plate on top only, then it's called single cover plate. If you have two plates, one is on the top and the other one is at the bottom, then we call it as double cover plate. Okay, so you have double strap and single strap. Now the terms, the important terms that we use, now these terms here are important. Now what are the terms that we use here? Now the first one is the pitch. Now when you look at this, okay, P-I-T-C-H, that is the pitch. Okay, now it is the distance from the center of one rivet to the center of the next rivet. So when you look into this diagram here, for example, okay, look into this diagram or the other diagram. So the vertical distance from the center of one rivet, to the center of this next rivet here, the vertical distance here is called the pitch. Okay, or if you refer from this center to this center here, it's also called a pitch. Okay, I repeat once more what it means by pitch. It is the distance from the vertical distance from the center of one rivet to the center of the next rivet, measured parallel to the seam, and it is usually denoted as P. Okay, P, the vertical distance here. Now, if let's say for example, when you refers to the horizontal distance between the center of one rivet to the center of the next rivet, we also call it as pitch, but we call it as the back pitch. The back pitch. Okay, then you have the diagonal pitch, which you are looking at the distance, the diagonal length between the center of the rivet to the center of the next rivet. That is called a diagonal pitch. Okay, or if it refers to this arrangement here, so from the center of this to the center of this, okay, the diagonal length here is called the diagonal pitch. So you have pitch, back pitch, and diagonal pitch. So the most important thing is what is a pitch. Okay, now margin or marginal pitch. Margin is the distance from the center of the rivet to the edge of the plate. It's called the margin. Now it is the distance between the center of the rivet hole to the nearest edge of the plate. Okay, is called the margin or the marginal pitch. So these are the examples, some of the examples of rivets which has conical head and a short body. Okay, now after looking at all the technical terms here, these are the important terms that you should know. What is a pitch, and especially what is a pitch and what is the margin. Okay, then you have to move to the failures of riveted joints. Now, if let's say for example it refers to lap joint. Okay, now the failure of the plates. Now, if let's say for example you have a plate, okay, initially the plate, before you can rivet, okay, rivet both the plates together, before you can rivet two plates together, you have to drill holes through both the plates. Then the shank of the rivet, the body of the rivet, have to be inserted through the hole. Then you have to use the device to punch to rivet, that means to close or to clamp both the plates together. Okay, we call it as rivets. Now, when two plates are placed together, lap joint, and you have the rivets here, and then when you apply forces at the side, you might, okay, cause failure. If let's say for example, okay, you are looking at the failure mode of the rivets, so there will be three possible failures that might occur on a riveted lap joint when you apply force that is along the axial direction, along the axis of the system. So this will cause one, the plate to tear when both the force that you apply is pulling, okay, to different direction, towards different direction. It might cause the plate, one failure mode is, it might cause the plate to tear into two parts. That is the first possibility that might cause the rivet to fail. Now the second one is when the rivet material is not as strong as the plate material, it might cause the rivet to be sheared, that means cut into two halves. Okay, it might cause shearing of rivets. First, it might cause tearing of the plates across the joint, across the riveted system. Okay, secondly, it might cause the rivet to shear. And lastly, when this thing here is subjected to compressive force or pushing force, the rod or the shank or the body of the rivets, which is within the hole, might also fail under crushing. We call it as crushing. So these are the three different failures that might occur on a riveted joint. Okay, tearing of the plates, shearing of the rivets, crushing of the rivets. So I'll be showing you all the three examples here. Now the first example is the tearing of the plates. Okay, across the plate. The tear will occur across the plate through the rivet hole. So you can see here the formation of the crack here. Okay, and then if this pull or this force P here or the load P here, okay, is being increased further on, or maybe it is subjected to static load, and then a continuous loading, it might cause the plate in here to be tear into two sections. So that is one of the failure mode of the riveted joint. Okay, now how to measure the strength of the rivet, okay, due to tearing? How much of strength that this can withstand? So you have to take force equals to stress times area, which is defined from stress equals to force over area. So the strength is the force of the load will be equals to stress times area. So where the P here is the pitch, okay, P is the pitch, D here would be the diameter of the rivet hole, T will be the thickness of the plate, Sigma T here, the subscript T here represents tensile, tearing stress or tensile stress. So the tearing area, the section which is being teared, okay, per pitch length. Okay, so this is the area. Now how to measure this area here? This is the section that we will be measuring. Okay, this is the section that we will be measuring. How much is this length? So you can measure this length here by taking the pitch of this, okay, minus half the radius here, the radius of the hole, and then half of the radius of the hole, which give you the whole thing here as the diameter. So when you take pitch minus diameter, actually it will give you this length here, okay, look at the pointer, that is this length here. Okay, so this length here is given as P minus D, where P is the pitch, D is the diameter of the hole. Now T will be the thickness of the plate, just like this. Okay, the thickness of the plate. Okay, so this will give you, okay, the area that is subjected to tearing. So if you want to measure the strength, that means the force or the load, so you can just take stress times area. This is the force or the load. So area times stress. So the area that we got will be this. So multiply by the stress, so you get the load. Okay, so this will be the tearing of the plate, one of the failure mode. So these are the examples that I've shown. You can see here. Examples that you can see here. So this shaded area here, this section here that we are measuring. Okay, so this will be the tearing area that is subjected to tear here. Look at the pointer. Okay, so this might be the cause. Okay, so that is for tearing. Now the next thing is the shearing of the rivets. How the shearing takes place. Because if you have lap joints, and when you apply force at each end, it will cause the plate to slide over each other. So as the plate slides over each other, the rivet that is sitting inside the hole will be sheared into two parts. Just for example here. Okay, so you have plates that is shaded in red and in blue. The rivet is running through the hole. So when you apply this force P here, it might cause the plates to slide over each other. So if the plates slides over each other, just now we have already discussed tearing of the plate might occur, or the shearing of the rivet might occur. So when you look at this diagram here, the shearing takes place here on this plane here. Look at my pointer. The shearing takes place at this plane here. So the rivets will be sheared into two parts. and for this also as well. Okay, so the number of rivets here shared is 2. The number of rivets shared here is 1. So here I give you some animation and how does the shear takes place. This is when it is having a lap joint or a butt joint with single cover, butt joint, or with a lap joint. So this might occur. This is called single shear. Here you can see, look at my pointer, it's called single shear. But then if the rivets is sitting inside a joint which has, okay, double cover plate with butt joint or a lap joint that is with 3 plates, that will cause the rivet to be sheared into 3 sections: section 1, section 2, and section 3. So we call this as one shear here, and the next one is here. So we can call this as double shear. Now the area that is subjected to shear now let diameter D be the diameter of the rivet or the hole, and tau here to be the shear stress, and N is the number of rivets. So N for this case is 1, N for this case is 2 rivets here. Okay, we are looking at the number of columns of rivets actually. So if you have 2 columns of rivets, then you have number of rivets to be sheared is 2. If it is 3 columns, then the number of rivets to be sheared is 3. If single column, then the number of rivets to be sheared is 1. So the area that is subjected to shear, that is the area of the rivets here, the area here. So this area here is given as pi d squared over 4, where the d is the diameter of the rivet or the hole. Okay, or even you can use pi r squared, doesn't matter. Now times n, n is the number of rivet. Now single shear, you times with 1. If double shear, you times with 2. If triple shear, you times with 3. Okay, this is theoretically only. But if you are going into the real practice, okay, the number of, let's say if it is double shear, usually we don't times with 2. We only times it with 1.82 or 1.8 something only. Okay, that is according to the standard, okay, boiler design. Okay, riveted joint for boiler shell. Okay, so for normal practice, we consider N would be equals to 2 if double shear. N is equals to 3 if it's triple shear. N is equals to 1 if it is single shear. So here, we multiply by 2 if it is double shear. The N here, remember the N here stands for the number of rivets. The 1 and the 2, the 1 I don't show here because we don't need to show multiply by 1. Here you can see multiply by 2 because it's double shear. And then the N stands for number of rivets. Okay, so we know that the strength will be the load or the force equals to stress, the stress here, that is shear stress, times the area. This is the area. So this N here is the number of rivets. So you have 2 rivets, then your N should be equals to 2. If you have single riveted joint, that means the N equals to 1. Follow? And tau is the shear stress. PS is the shearing load. Then the third case is the crushing of the rivets. Now crushing takes place, the same thing, you have a hole and the rivet is running through the hole. Okay, the shank of the body that is sitting inside the hole, when it is subjected to compressive force or pushing force, the shank of the body that is within the hole will be crushed, compressed. But when we measure the area that is resisting the crushing stress, we should be taking the projected area and not the circumferential area. We take the projected area, and how to consider the projected area I will show you in my slides. Okay, so D is the diameter of the rivet hole again, T is the thickness of the plate, but now the sigma C here is the crushing stress or the compressive stress, and N is the number of rivets that is crushed. Now the area that is subjected to crush, will just take the center plane area of the rivet. That is given as the diameter of the rivet times the T. So that means it's directly a rectangular section, which is the center plane of the rivet. That is also called the projected area, where anything that is subjected to pressure acting from all directions or is subjected to compressive force acting from all directions, usually we consider what is known as the projected area. So the projected area, the load that they take, or the strength is given as stress times the total area. Stress, that is the compressive stress or the crushing stress, multiplied by the total area. The total area is number of rivets times diameter of rivets multiplied by the thickness of the plate. So these are the diagrams. This is an example how you are going to measure the crushing area. So now you see this rivet here, actually if this is a lap joint, now means there is a part of the rivet is in the upper plate, and then another part of the rivet will be seated in the lower plates if it is a lap joint. So we only consider one part. So we take the plane area, the projected area of the rivet, that means the center plane area, which is equals to the diameter of the rivets multiplied by the thickness of the plate. So when you consider the thickness of plate is a single plate only. Okay, so that means you are looking at one part. Okay, you don't have to look at both the parts. Okay, one part is enough. So that is the thickness of the plate. So these are the failure modes of any riveted joint when the riveted joint is subjected to force which is acting along the axis of the riveted system. So there are three failure modes. One is tearing of plates, two is shearing of rivets, three is the crushing of rivets. Please bear in mind, okay? So I think that is all for this part. Okay, now another part, okay, another small section, sorry, the efficiency of a riveted joint. So how we are going to measure the efficiency? So usually if the plate, before you drill holes, okay, before you drill hole, you have a solid plate. So the area of the solid plate that you measure will be based on pitch. This lowercase letter p here is the pitch. I hope you still remember what is pitch, multiplied by the thickness of the plate. This is the solid area, the plate area, okay, based on a pitch. Okay, that means the distance of a pitch multiplied by thickness. Okay, solid plate multiplied by the stress, the tensile stress. This will give you the tensile strength of a solid plate without any holes drilled in it. Okay, then the efficiency of the joint is defined as, so you have to first calculate the tearing, the load, okay, the load or the strength of the plate subjected to tearing, okay, the strength of the plate subjected to tearing, and then the strength of the rivet subjected to shearing, and then the crushing strength of the rivet. And then after calculating all these three values, you have to choose the smallest value among these three values here. You have to choose the smallest and divided by the strength of the solid plate that we considered just now. Okay, then multiplied by 100%, you will be able to determine the joint efficiency. Okay, that's all. Thank you.